Hey guys, welcome to Supernal Tutorials. So this is gonna be our mathematics videos for grade 12s, right? So we're gonna start off with trigonometry. We're gonna be proving identities, right? So our first question, we're required to prove this, right? So I'm not really gonna be writing notes. I will answer questions, right? And as I answer these questions, I'll be mentioning all the little tricks there and there, so you gotta stop the video and actually write these things that I'm saying. Okay, the trick about proving these kind of questions, right? We need to make sure that, okay, we're gonna start off with the left hand side, right? So we need to make sure that our terms on the left hand side are actually the same. Then we can be able to simplify it until it gives us the right hand side, which is tan x, right? So looking at the top part, we can see that we can actually change tan x and then relate it with sine 2x, right? So what I'm going to do, I'm going to take the denominator and shift it to the side. So it's going to be 1 over 2 sine x squared, right? And then we actually focus on the numerator. This is going to be 2 sine x over cos x minus sine 2x, right? Okay, so that we don't make mistakes, right? Okay, so looking at this term, right, we can actually simplify this, and to do that we're gonna make cos x our denominator, and then it's gonna be like this. As you all know how to deal with fractions, right? So our denominator is cos x, right? So cos over cos, that's 1. Then we multiply it with the numerator, so it's going to be 1 times 2 sine x, right? And then this side we got what? We don't have a numerator, so it's simply going to be sine 2x multiplied by cos x, and then multiplied by this. Now if you look closely, right, sine 2x is an identity, so we can actually change this and see how this thing can be related, right? So it's going to be 2 sine x minus 2 sine x cos x. This is a identity of sine 2x. Multiplied by 1 over 2 sine x squared. I'm running out of space. Let me switch the page. Okay, so this is the term we had on the previous page. So looking at this, right, you can see that with these two terms we have 2 sine x, which is common in both terms, right? Okay, so we're gonna factor out the 2 sine x. So that term divided by 2 sine x, it's going to give us a 1, right? Minus, then on the side we're going to remove what? 2 sine x. We're going to be left with cos x multiplied by cos x, so that gives us cos x squared, right? Then over cos x, which is our denominator, right? Then multiply by 1 over 2 sine x squared, right? Looking at this, 1 minus cos x squared introduces another identity. This identity comes from sine x squared plus cos x squared, which is equals to 1. So if you actually move around those terms, you will see that 1 minus cos x squared is equals to sine x squared. So this is going to be 2 sine x multiplied by sine x squared, right? Now looking at this term, it's going to be like this, right? So we're going to bring them back together, right? So it's going to be cos x multiplied by 2 sine x squared, right? And then we have 2 sine x multiplied by sine x squared. So looking at these terms, you will see that we can actually cancel out sine x squared because it's on the top and on the bottom. So yeah, so this is going to give us what okay, also notice the 2 right here. So this 2 will cancel that 2 right there. Actually, it's not even cancelling, right? Something divided by itself gives us 1. So yeah, that's what happens. And then we're left with sine x over cos x. This is equals to what? Tan x, right? So if you notice, this tan x is equals to what? Our right hand side, which is what we were required to prove. So with all these steps, we have actually proven that that term is equals to tan x. Thank you for watching. Guys, please comment after watching this video and actually give us feedback and tell us how we can improve. All criticism is good, right? And apologies for the background noise. Yeah, it's a lockdown kind of situation, so it's a full house. Sharp.